Okay, here we go. Math 2, Mr. Trutna. We're going to go over Unit 9. Worksheet 3, we're going to do numbers 3 through 14 on this worksheet. There's more problems, but we're just going to go over these right now. Each one we're going to be factoring with a GCF. GCF, greatest common factor. Okay, so the joke of the day, I am on a seafood diet. Now, if you want to know the end of the joke, you got to watch the rest of the video. The joke will come at the end. Okay, we call that a carrot in the radio business to keep you guys listening. Okay, so number 3. So if you notice, for numbers 3 through 14, the instructions say factor out the greatest common factor for each polynomial. Okay, so the key is right here. Don't get caught up in some of the instructions. Okay, we already know what a polynomial is. All this is saying is that each one of the problems that we're going to do are going to be a many-termed mathematical expression. Remember, poly means many, nomial means terms. Okay, and what we're going to do is we are going to be factoring, and we're going to be factoring out the greatest common factor. Okay, so here's how we do it. So my first number 3, I have 9t plus 3. So what we're going to do is we're going to take the first term, which is 9t, and we're going to break it down into its prime factors. So 9 breaks down into 3 times 3, and t is just t. Then I'm going to put a minus sign, and then I'm going to take the next term 3, and I'm going to break that down, or I'm going to factor that down into its factors. Well, 3 cannot be factored at all because it is a prime number. That's the term we use if something can't be factored. So 3 is just 3. Okay? And so now what I'm going to do is I'm going to look for the greatest common factor. Okay? So here's my factors, 3 times 3 and t, and 3. I'm going to look for what's common in each one of these factors lists, and you can see that out of these terms each list has in common the number 3. Okay, so that means that's my greatest common factor. Okay, so what I do is I put an equal sign next to my original term here, which is 9t minus 3, and I'm going to put, I know my greatest common factor is 3, so I put a 3. Then I'm going to put a parentheses next to that. So next to the greatest common factor, I'm going to put a parentheses, and then I'm just going to simply write down what is left over from my list. So my first list, you can see what is left over is a 3t. So I write 3t. A minus sign is left over, so I put a minus sign, and now in this second list, if you notice, okay, there's nothing left over because I've already taken this 3 and I've moved it here. The greatest common factor is moved there. So there's a mathematical rule: if there's nothing left over in the list and you're factoring, you put a 1. So 9t minus 3, when I factor it, it becomes 3 times the quantity 3t minus 1. Okay, well, let's see if that works. So what that means is if I multiplied this factored form back out, it should equal my original expression, my original terms. Okay, 3 times 3t is 9t. 3 times negative 1 is negative 3. Number 3 works out. Okay, and that's the process that we're going to do in each one of these problems. Okay, so number 4, 12j to the third plus 28. I'm going to take the first term, 12j to the third, and I'm going to break it down into its prime numbers. Okay, so 12 is 6 times 2, but 6 is 3 times 2, so I could think of 12 as 6 times 2, but 6 is 3 times 2, so 12 is 3 times 2 times 2. J to the third just means j, j, j. I have a plus. Then I go to the second term, 28. And I'm going to write down the prime factors of 28. Well, 28 is 7 times 4, but 4 is 2 times 2, so 28 is 7 times 2 times 2. Okay, always the first step when we're looking for a greatest common factor. Now I look at both of my lists here, and I'm going to see what is in common. And in order for something to be common, it has to be in both lists. So you could see they each have a 2 in common, and they each have another 2 in common. Okay, so what's in common is 2 times 2, which is 4. So that's my greatest common factor. So up here I write equals and I put 4. Why did I put 4? Because the greatest common factor is 2 times 2, that is 4. Then I put a parentheses next to my greatest common factor, and inside the parentheses, what I'm going to multiply the 4 by would be what is left over. So you can see in this first list, I have a 3, a j, a j, a j left over. So that means that's 3j to the third power. I have an addition symbol, so I put plus. And left over in the second list, after the 2 and the 2 aren't there anymore because they were here, I have a 7. Okay, so number 4 is going to factor into 4 times the quantity 3j to the third plus 7. Let's see if I did it right. 4 times 3 is 12, so I get 12j to the third. 4 times 7 is 28, so I get 28. That ensures that I did that one right. Okay, number 5. All right, so I'm going to take 72, x to the third, and the first thing I'm going to do is I'm going to break down 72 into its prime factors. 72 is 8 times 9, but 8 is 2 times 2 times 2, and 9 is 3 times 3. So 72 is 2 times 2 times 2, that's the 8, times 3 times 3, and then I have x squared, so that's xx. I put a subtraction symbol. And then I'm going to factor down 63. Well, 63 is 9 times 7, but 9 is 3 times 3, so 63 is 3 times 3 times 7. And then I'm going to get out my highlighter. I like to use a highlighter to highlight what's in common in each list. So you can see each list, they share 2 3s. Okay, and that's it. That has a 7 in it, but that list has no 7s in it. This list has 2s, but there's no 2s here. This list has x's, there's no x's here. So my common factor, my greatest common factor is 3 times 3. So that's 9. So that means number 5, my greatest common factor is 9. I'm going to write that down, and then I'm going to put a parentheses, and inside the parentheses, I'm going to put what is left over after you factor out the 3 times 3 in each one of the lists. So you can see here, left over is 2 times 2 times 2, xx. That would be 2 times 2 times 2, 8xx, 8x squared. So I have 8x squared. A subtraction symbol, so I put minus. Left over in my second list is just a 7. Okay, so number 5, there's my factor. Moving on to number 6. Now I have a trinomial when I get to number 6. No big deal when you get a trinomial. So what you're going to do is you're just going to factor each one of the 3 terms here. So like in numbers 3, 4, and 5, when I factor down the 2 terms, I just have to do it 3 times. So 12 is 4 times 3, 4 is 2 times 2, so 12 becomes 2 times 2 times 3. K to the third is K, K, and 3 Ks. Okay, now I go to my next term. 9, I put a minus sign, sorry. Then I factor 9k squared. 9 is 3 times 3. K squared is KK. Then I put an addition symbol, plus 6 times 6 is 3 times 2. Okay, now I have 3 lists now. I have this list, I have this list, I have this list, and I need to find the greatest common factor. So, in order for something to be a greatest common factor, it has to be in all 3 of the lists. So you can see all 3 of the lists have in common a 3, and that has a 2, but there's no 2 there. So there's not a 2 in common in all 3 lists. The first list and the second list have k's, but the third list doesn't have a k, so that means my only common factor is a 3. So I put equals, and I'm ready to factor. So my greatest common factor is a 3. Then next to my greatest common factor, I'm going to put a parentheses, and I'm going to write the leftover of each list. So the first list, leftover, 2 times 2, 4, k to the third. So I have 4k to the third. I put a subtraction symbol. The second list, what's left over? A 3, a k, and a k. So that's 3k to the second. I'm going to have to squish this together. I put an addition symbol. In the third list, what's left over is 2. So there's my factor of number 6. That's what it factors into. All right, number 7. So let's take the first term, 30, and we're going to write out the factors of 30. 30 is 6 times 5. 6 is 3 times 2. So I get 3 times 2 times 5. N to the third is n, n, n. Minus. Go to the next term, 18n squared. I'm going to factor that down. 18 is 9 times 2, 9 is 3 times 3, so it's 3 times 3 times 2, n to the second is n, plus. Now I'm going to factor 54. 54 is 9 times 6, 9 is 3 times 3, 6 is 3 times 2, and then I have an n. Okay? So there is my factors of each one of my individual terms of my polynomial that I started with. And now I'm going to see what is in common in each one of the lists. So right away I see that each list has in common a 3. They also have in common, do they have a 2 in common? Yeah, they do. So each list has a 2 in common. And each list has an n in common. Okay, putting those together, 3 times 2 is 6, and n is 6n. So you can see each one has 3 times 2, n. 3 times 2, n. So that means my greatest common factor is 6n. I write that down. Then I put in parentheses, and inside the parentheses I'm going to write the leftovers after the 6n is divided out. Okay, taken out. So in the first list I have 5nn, so I have 5n squared left over from my first list. Then I have a subtraction symbol. My second list has a 3 and an n left over, so that's 3n. Then I put addition symbol, plus. And then my third list has a 3 times 3 left over, that's 9. So there's my factor for number 7. 6n times the quantity, 5n squared minus 3n plus 9. All right, continuing, number 8, here we go. All right, the numbers are getting bigger and stuff like that. Big deal. We're in high school. We can do these numbers. So 32, what does 32 factor into? Well, that's 8 times 4. But 8 is 4 times 2. But 4 is 2 times 2. So 8 is 2 times 2 times 2. 4 is 2 times 2. Z to the fourth means z, 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 z. I hate when problems have 2's and z's in them. They start looking the same to me. That's why I put the little line for the z's. Then I put a subtraction symbol. Now I'm going to take 80z to the third, and I'm going to factor that down into nothing but prime numbers. 8 times 10 is 80, but 8, we already figured out, is 2 times 2 times 2. 10 is 2 times 5. And then I have z to the third, so that's z, z, z. Then I put an addition symbol, and now I have to factor 112. This is where a calculator will come in handy if you're not very good with your math facts in your head. Okay, well 112 I know is 56 times 2. Okay, 56 is 8 times 7. 8 is 2 times 2 times 2 times 7 times 2. That's 112. Z to the second, z, z. Okay, so once I make my list, now I'm ready to find see what's common in all the lists. Okay, so I got a bunch of 2's in each list. How many are common? This last one right here, I got 4 2's. I got 4 2's here. All right, so you can see there are 1, 2, 3, 4 2's common in each list. 1, 2, 3, 4 2's. 1, 2, 3, 4 2's. All right, so 5 here, but no 5's in either one of those lists. There's a 7 there, but I have z's. And you can see that there are at least 2 z's in each list, so that means there's a z and a z that's common, okay? So each list has in common a 2 times 2 times 2 times 2 and a z and a z. Okay, well 2 times 2 is 4, times 2 is 8, times 2 is 16, z is z to the second, so that means my common factor, my greatest common factor, is 16z to the second power. I'm going to write that down. That's my first factor that I'm going to multiply. Then I'm going to multiply that by the leftovers. What's left after I divide out a 16z to the second from each list? So the first list, you can see I have left over a 2, a z, and a z. So that's 2z squared. Then I put a subtraction symbol, minus. Second list, I have left over a 5 and a z, so it's minus 5z. Then I put an addition symbol. And on the third list, I have left over a 7, so I put plus 7. So that would be my factors using my greatest common factor of number 8. Okay. Now you need to write both of these, by the way. I didn't say that earlier. Okay. All right. I'm going to talk really loud. I'm walking around the classroom here. Got to get my lights turned back on, which means that my screen disappeared for a second. Let's let it come back. Okay. So you got to write down both of these. Not only the greatest common factor, but you have to write down what's in parentheses too, because factoring means we're finding two terms that multiply to make the original term that I have. All right, number 9, 12n to the 4th plus 16n to the 3rd plus 20n squared. So I'm going to take my first term, 12n to the 4th, and I'm going to break it down into its prime factors. 12 is 4 times 3, but 4 is 2 times 2. So that's 2 times 2 times 3. N to the 4th is n, 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 n. Plus 16 is 4 times 4, but that's 2 times 2. So I get 2 times 2 times 2 times 2, that's 16, n to the 3rd, n, n, n. Plus, now we need to factor down 20. 20 is 4 times 5, 4 is 2 times 2, so that's 2 times 2 times 5. N to the 2nd is n, n. Okay, so now I get out my highlighter and I'm going to find what's in common in all three of my lists. Okay, so you can see that there are 2 2's in each list. So that's 4. 2 times 2 is 4. Got a 5. Nope. Got a 3 here, but no 3's there. And I got some n's. So each list has 2 n's in them, at least. So what's common is n and n. So you can see what's in common in each list is 2 times 2, 4, n, n, 4n squared. 2 times 2, 4, n squared, 4n squared. So my greatest common factor is 4n squared. I put that down. Then I'm going to put in parentheses the leftover parts of this. I'm going to have to write it. Oh man, I'm going to run out of room here. So number 9, I'm going to write it up here. So I have 4n squared. Then I'm going to put in parentheses the leftovers. Okay, the first list, I have a 3 leftover, and I have an n and an n. So that's 3n squared. Put a plus, because I have a plus symbol. Second list, I have a 2 times 2 times n, so that's 4n. Okay, then I put plus, because I have an addition symbol left over. Third list, I just have a 5. So there is my factors for number 9. Okay, number 10, 24y to the 6 plus 36y to the 4th plus 42y to the 2nd. So first thing that I do is I'm factoring by finding the greatest common factor. Okay, so I'm going to take the first term right here, which is 24y to the 6. Well, 24 breaks down into 8 times 3, but 8 is 2 times 2 times 2 times 3. That's 24. Y to the 6, y do they put so many y's? Y. Plus, now I'm going to factor out 36. 36 is 6 times 6, but 6 times 6 is 3 times 2. So I'm going to get 3 times 2 times 3 times 2. That's 36. Y to the 4th, y. Plus 42, y to the 2nd. 42 is 21 times 2. 21 is 7 times 3. So I get 7 times 3 times 2 is 42. Y to the 2nd is y. Okay, now I'm going to find what's in common in each one of the 3 lists. Okay, so let's start with the y's this time. So I have 2 y's in each list, so that's common. So that'd be y squared, because y times y is y squared. Then let's look at the numerals. So do I have a 2 in each list and a 3 in each list? Absolutely. So I have a 2 and a 3 in each list. Okay, so that means my common factor in each list is 2 times 3, 6, y squared. 3 times 2, 6, y squared. 6y squared. That's my common factor. So I'm going to write it down here. I have more room. So I write 6y squared. Then I'm going to put in parentheses the leftovers that ultimately I would multiply 6y squared by in order to get back to my original term here. Okay, so you can see leftover, what's left over? 2 times 2, that's 4, y. 4y to the 4th. Put an addition symbol. Plus, what's left over in the second list? 3 times 2, that's 6, y. So 6y squared. put an addition symbol, plus what's left over in the third list? Just a 7. So there's my factors for number 10. Moving on to number 11 here. So I have 7q to the 5th, 21 plus 21q to the 3rd minus 49q. Following along with the same thing, hopefully you're starting to get the idea. I'm going to factor 7q to the 5th. 7 is prime. Q to the 5th. Q, 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 Q. Those look like 9s. Drives me crazy. All right, so then I put an addition symbol. Now I'm going to factor 21q to the 3rd. 7 times 3 is 21. Q to the 3rd. That's easy. It's Q, Q, Q. Probably should do them cursive. They look a little bit more like Q's instead of 9s. And then I'm going to put a minus sign and a subtraction sign. 49 factors down into 7 times 7, and then I have a Q. Now I'm going to look to see what's in common between all 3 lists. So we can see they all have a 7. They also have 1 Q in each one of the lists. So that means my greatest common factor is 7Q. So I put equals 7Q. There's my greatest common factor, and then I'm going to draw a parentheses, and I'm going to write down what would I multiply 7q by in order to get back to my original trinomial, and that's the leftovers. So the first list, I have q, 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 q left over, q to the 4th. I have an addition symbol left over, so I have to put plus. In the second list here, I have a 3, a q, and a q left over, 3q squared. I have a subtraction symbol, so I have to put a minus in here. And then in the third list, the only thing left over is a 7, so there's my factors for number 11. Okay, number 12, this 12 and 13 and 14, a little bit different, but really not that much different. The only difference is that we have multiple variables, C's and D's, X's and Y's, M's and N's, okay? No big deal. We're going to do it the same way. You'll see how we do it. So, number 12, I've got a factor. I'm told to find the greatest common factor. So, I'm going to take the first term and I'm going to factor it down. 13, that's a prime number. You can't factor it, so it's just 13. C is C. D to the 3rd is D, D, D. Then I put a plus. Then I'm going to factor the second term. Okay, 39 is 13 times 3. All right, C to the 2nd, C, C. D to the 2nd, D, D. So now I'm going to look and I'm going to see what's in common in each one of the lists. Well, you can see they each share a 13, that's common. They each share a C, so there's a C common, and they each share 2 D's, D, D. So that means in common is 13C, D, D. 13C, D to the 2nd. 13C, D to the 2nd is common in each one of the lists. So I put an equal sign, I put the common factor, greatest common factor, 13C, D to the 2nd, and then I'm going to draw a parentheses, and I'm going to put inside what I would multiply 13C, D to the 2nd by in order to get back to my original binomial in this case. So, what's left over? This is how we do it. Oh, there's only a D, so I put a D right there. I have an addition symbol left over. What's left over in the second list? You can see I have a 3 and a C left over. So there's my factor. Number 12 factors down into that. Okay? Number 13. My first term. Let's factor it. I got to find the greatest common factor. 5 is prime. X to the 3rd is X, X, X. Y to the 4th just means Y, Y, Y. And by the way, if I write X, 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 I'm saying X times X times X. Times Y times Y times Y times Y. Really, that's what I'm saying. I bring down a subtraction symbol. Now I'm going to factor out prime factors of 25. That's 5 times 5. X is just X. Y to the 2nd is Y times Y. Okay? And so now what I'm going to do is I'm going to find what's the greatest common of each one of my factors lists. Well, you can see they have in common a 5. They each have in common an X. And they have a Y and a Y. A Y and a Y. So what's the common factor? It's 5X. 5 times X, 5X, Y, Y. 5X, Y to the 2nd. Each of them, 5X, Y to the 2nd. So that means my greatest common factor is 5X, Y to the 2nd. I write that down. That's going to be what I'm going to be my first thing that I'm going to multiply, my first term. And then I'm going to put in parentheses what I would multiply 5xy to the second by into to get 5x to the third, y to the fourth, minus 25xy squared. And that's going to be the leftovers. X and x squared, y squared. So I have an x squared, y squared left over from my first list, my first terms. Then I put a subtraction symbol. The only thing left over in the second list is a 5. So there's my factors for number 13. Last one, number 14. Okay, so I'm going to take my first term, 42m to the 5th n. I'm going to factor it down. 42 is 21 times 2. 21 is 7 times 3. So 42 is 7 times 3 times 2. M to the 5th n is m, 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 n. Put an addition symbol. Then I'm going to factor my second term, 28 n to the 4th. Put it right there. 28 is 7 times 4, but 4 is 2 times 2, so 28 is 7 times 2 times 2. M to the 4th, m, 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 m. Ugh, kind of messed up there. Lots of m's. Getting hungry. Bad joke, sorry. Okay, what's in common? 7. Each list has 2. Each list has 4 m's. 1, 2, 3, 4. 1, 2, 3, 4. There's no n's in the second list. So, what's in common? 7 times 2, 14, m, 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 m to the 4th. So my common factor, my greatest common factor is 14m to the 4th. Then I put parentheses. After that, what would I multiply 14m to the 4th into? What would I distribute it to make my original term? Okay, the easy way to figure it out is see what's left over. So I have a 3, an m, and an n. 3m, n. An addition symbol, so I put plus. What's left over here? A 2. So I put a 2. There's my answer to number 14. Okay, you guys, so there we go. Best of luck to you on that problem. So, the joke of the day. You waited it out. Good job. I'm on a seafood diet. You're going to be probably not disappointed. When I see food, I eat it. Get it? I'm on a seafood diet. When I see food, I eat it. Okay, guys, study hard, learn well, and good luck.